Hi, I'm Alex. This is Oh, That's Why, a podcast about JavaScript, finally making sense. Let's dig in. I want to start with something that genuinely confused me for a long time. You have a function. You call it on line 3. You define it on line 10. You run the code. It works. How? That function doesn't exist yet at line 3. By any reasonable reading of how a program should run, calling something that hasn't been defined should throw an error. And yet it doesn't. It just works. Now try it with a variable. Declare a variable on line 10 with const. Try to use it on line 3. Run the code. Error, reference error, cannot access before initialization. Same file, same principle, completely different result. For a long time, I assumed this was just one of those JavaScript quirks you had to memorize. Function declarations work before they're written. Variables don't. Fine, moving on. But that explanation is incomplete, and incomplete explanations lead to bugs you can't explain. So let's actually understand it, because once you do, 3 episodes of groundwork are about to pay off at once. Think about a chef preparing for a dinner service. Before anything gets cooked, before a single pan goes on the stove, the chef reads the whole menu. Every dish, every recipe, every technique. The whole night, front to back, before service begins. Now, here's where it gets interesting. Not everything gets prepared the same way during that read-through. Some things the chef prepares completely. A sauce that takes 3 hours, they start it immediately. They read it in the recipe and they make it right then, because by the time a customer orders it, it needs to be ready. When the order comes in, the sauce is sitting there, finished. Other things the chef only notes. A side dish that comes together in 2 minutes. They don't make it in advance. They write the name on the prep list, hold a spot for it, and then make it fresh when the order arrives. During the read-through, only the name gets written down. The actual dish doesn't exist yet. And then there's a third category. A new ingredient the restaurant just started using, where the head chef said, "Don't use this until you're certain of the order. Don't even touch it until you know exactly what it's going in." It's noted, it's reserved, but it's off limits until the moment is right. That is hoisting. The read-through is the memory creation phase. The chef is the JavaScript engine. And how completely something gets prepared during that phase depends entirely on what kind of thing it is. Here's what's actually happening under the hood. Episode 1, we talked about the memory creation phase. JavaScript reads your entire file before running a single line. During that scan, it registers everything it finds. But it doesn't register everything the same way. Function declarations, the ones that start with the word function and have a name, get stored completely during the memory creation phase. The entire body. Every line of code inside them. When the execution phase starts, the function is already fully formed and ready. That's why you can call it on line 3 even if you write it on line 10. By the time line 3 runs, the function has already existed for the entire scan. Variables declared with var behave differently. During the memory creation phase, var variables get registered. The name goes on the whiteboard, but the value doesn't. The variable exists, but it's set to undefined. When line 3 tries to use a var variable that was assigned on line 10, it finds the variable but finds it empty. No crash, just undefined. Which, as we talked about in episode 1, is not the same as not existing. And then there's let and const. These are the new ingredients. During the memory creation phase, let and const declarations are registered. The name is noted, but they are placed in something called the temporal dead zone. They exist in memory, but they are completely off limits until the execution phase reaches the line where they're declared. Touch them before that line, and JavaScript doesn't give you undefined. It throws a reference error. Cannot access before initialization. This is not a bug. It is a deliberate design decision. The temporal dead zone exists to protect you. With var, you could use a variable before it was ready and get undefined back, a silent failure that could produce wrong results with no indication something went wrong. With let and const, JavaScript actively prevents that. It won't let you touch the variable before it's been properly initialized, and it tells you clearly when you've tried. The temporal dead zone is JavaScript saying, I know this variable exists, but you're not allowed to use it yet. So to put it all together, function declarations, fully hoisted, available immediately. Call them anywhere. Var, hoisted but empty, exists as undefined from the moment the memory creation phase runs. Let and const, hoisted into the temporal dead zone. Technically registered, completely untouchable until their line. That's hoisting, not magic, not a quirk, just the memory creation phase doing exactly what we said it would. 3 episodes of context, and now the traps actually make sense. The var trap is the classic one, and it is everywhere. You declare a variable with var inside a loop or in a function and reference it somewhere above that declaration. Maybe in a conditional, maybe a log statement you added for debugging. You get undefined instead of the value you expected. No error, no warning, just wrong output. And because it doesn't crash, you might not notice for a while. I have spent so long on bugs caused by exactly this. The fix is simple enough. Use let and const for new code. The temporal dead zone exists precisely to catch this class of mistake. If you accidentally reference a variable before it's ready, you get an immediate, clear error, instead of a silent, undefined, corrupting your output somewhere downstream. The second trap surprises developers who think they understand hoisting. A function expression is when you assign a function to a variable, and that assignment follows the variable's rules, not the function declaration rules. If you use var, the variable is hoisted as undefined. Calling it before the assignment gives you a type error. You're trying to call undefined as a function. If you use const, it's in the temporal dead zone, so you get a reference error. The word function appears in both cases, but the hoisting behavior belongs to the variable, not the function. The third trap is more conceptual, but it causes real confusion. Some developers hear the word hoisting and picture JavaScript physically moving code, like declarations get cut and pasted to the top of the file before it runs. That's not what happens. The code stays exactly where you wrote it. What changes is the order in which things get prepared. The memory creation phase happens before the execution phase. Nothing moves. JavaScript just reads ahead, and what it does with what it reads depends on the type of declaration. Understanding that, preparation order versus code movement, changes how you reason about every variable and function in your code base. Hoisting isn't magic. It's just the memory creation phase doing exactly what we said it would. 4 episodes in, and everything is connecting. The 2-phase model, the execution context, the call stack, and now hoisting, these aren't separate topics. They're one coherent system. Each piece explains the next. The companion article on Medium has a visual breakdown of exactly what JavaScript stores during the memory creation phase for each type of declaration. Link is in the show notes. Next week, scope. Now that you know how JavaScript builds its rooms, prepares their contents, and stacks them on the call stack, We find out which rooms can see into which other rooms. It's the answer to a question you've probably asked yourself many times without quite realizing it. I'm Alex Vega. This is Oh, That's Why. The moment hoisting stopped feeling like a quirk and started feeling like a consequence, everything else got easier. Hope today was that moment. See you next week.